Hi everyone, Siddharth here. This is the fourth video in the series of Spark Basics. In this video, we are going to talk about two useful concepts when we talk about Spark. The most crucial out of both of these two is the shuffle concept. And the second key concept is SQL Engine. Right. So let's get started. The first thing that we need to understand is SQL Engine and its role in overall query execution. So we have throughout our videos coded using an object called as data frame. That is the data structure that we have used for our coding in all the videos. The second kind of data structure that can be used is called as RDD, which you see at the bottom of this visual. Now there is another. Now, how is data frame different from an RDD? An RDD is a low-lying interface or a low interface of coding in Spark, and a data frame is a high-level interface. So for example, if you have to do a group by operation in data frame, it is fairly simple. But to do the same operation in RDD, it is extremely complex. With the latest version of Spark and with even long back, they started moving RDD to the backend and coming up with data frame so that it is easy for people to code and people don't have to really figure out each and every piece of code and forget the optimization in between. So how data frame does optimizations is what this SQL engine all about. So when you code something using a data frame object or a data structure called data frame, internally all your code is getting converted into an RDD kind of a code. So this internal conversion is being handled by SQL engine. There are many other things that SQL engine does. When you submit your code, which is in data frames, Spark data frames, at that moment, SQL engine will try to understand if there are any formatting issues or if there are any syntax errors in your code. Then it will try to come up with multiple plans or multiple DAGs that your code can take. And then it will figure out what is the best suitable execution plan for your code. And taking that best suitable physical execution plan, it will convert your code into a low level RDD code. And that RDD code actually gets submitted for execution, right? So even though you are writing in data frames, all of your code is getting converted into an RDD object level code through SQL engine. The same concept can be applied to Spark SQL. Whatever you are writing in Spark SQL, the SQL interface, that also goes through the same layer of SQL engine and gets converted into RDD. So all your optimizations which were done by the developer when he used to code in RDD, all those optimizations, most of them are now taken care by SQL engine because SQL engine will see all the execution plans available and will pick the best execution plan. It will do multiple other optimizations that we need to do manually when we used to code using RDD. That was a quick glimpse of SQL engine. Now let's move ahead to another key concept called as shuffle. So we all have been seeing in other blogs or net or videos that shuffling is the problematic area in Spark, and this is what causes a lot of bottleneck or a performance bottleneck in Spark jobs. Let's take an example to understand what exactly is happening when we do a shuffle operation. Here we see a data set of medicines. For example, Crocin is a fever medicine, Dolo is also a fever medicine. And the third column, sales, tells you how many strips of that particular medicine is being sold in that shop. Same way you have vitamin tablets like Zincovit, and then you have antibiotic and their sales. For example, AZ is an antibiotic, and there were 30 strips being sold in one single day at a specific shop. So this is the data all about. Now we are trying to launch this query, which is given on the right-hand side on this data set. What this does, this query tells us the category level sales of the categories. So for example, the output would be fever. For fever, what is the total sales? If we look at this data, for fever, the total sales was 20 plus 10, 30. For vitamin, the total sales was 6 plus 5, 11. For antibiotic, the total sales was 30 plus 4 plus 9, which is 43. Right? But we are trying to filter out on a condition wherein medicine not equal to Dolo. And another thing which we are doing is we are putting a having clause in this Spark SQL statement wherein the total sales should be less than 40. So that means the sales of antibiotic should not appear in the result. So because antibiotic is sales are 30 plus 4 plus 9, which is 43, but we only want the antibiotic or the category sales which are less than 40, right? So antibiotic sales will disappear from the result. So let's see when we launch this query in Spark, what exactly happens. So I've given small minute steps which details what is happening in different machines. So for example, step one, your data resides in two different machines. In machine one, you have data for crocin, zincovit, AZ, azethral. In your machine two, at the bottom, which says executor two, the data is of amoxicillin, dolo, and bacosules, right? So your data is distributed because it is Spark, which is a distributed engine. In step two, what exactly we are doing? So shuffling, it's the clause that we are using is group by. Group by is the concept, is the clause that actually causes shuffling. So in this complete statement, the first step which is getting executed is the where clause, which is medicine not equal to dolo. So as you can see, this dolo fever 10, which was available in machine 2 in step 1. So this is step 1 from vertically, got disappeared in step 2 in machine 2, right? So now dolo is missing here. So first we applied the where clause. After that, what we did, since it is a grouping operation, grouping involves shuffle operation. So that means we have to move the data belonging to the common category into a single machine. To detail, we have antibiotic AZ and azithral in machine 1 in step 2, and amoxicillin, which is again an antibiotic, but that's sitting in executor 2 or the second machine. So we want to bring all the categories which are common in one machine. So antibiotic in step 3 comes in machine 1, right? So AZ, azithral, amoxicillin, all of them together are in machine 1 now. So this is shuffling. You are actually moving the record amoxicillin antibiotic 9 from machine 2 in step 2 to machine 1. Same way, all the vitamin related tablets data came into machine 2 in step 3. You can see here bacosules and zincovit came in machine 2. So this was the shuffling that happens. Once shuffling is done, then comes the aggregation operation. So we basically want to do a sum based on category. So for fever, we have 20 sales. For antibiotic, we have 30 plus 4 plus 9, which is 43 sales. In executor 2 or machine 2, we have vitamin sales, which is 11. On top of that, in step 5, we apply having clause. So having clause sales, sum of sales should be less than 40. So that means antibiotic 43 disappears. So in step 5, we remain with fever 20 and vitamin 11 in machine 2. And then we group them together or we add them together in last step. Right? So this gives us the result. So the most problematic bottleneck in this entire piece was the shuffle operation because that required moving data from one machine to another. This also brings us to another topic, another important key topic which we should figure out is a wide transformation and a narrow transformation. So what is a wide transformation? So as you know, group by is a transformation, right? Now, when we want to do group by transformation, we are shuffling the data. You can see step 2 and step 3. We are moving the data for all the antibiotics together. So amoxicillin antibiotic 9, which was in machine 2 in step 2, moved to machine 1 in step 3, right? In machine 1 in step 3, all the antibiotics are together. So that was shuffling. So when we are moving the data from one machine to another during a transformation, that is called as a wide transformation. A narrow transformation is one wherein we are not moving the data between the machines. We also did something called a sum here. Between step 3 and step 4, you can see that the machine 1 had fever and antibiotic, right? We just use the output of machine 1 to aggregate or use some function and came up with the result fever 20 and antibiotic 43. 43 because you have AZ 30, azithral 4, and amoxicillin 9. So you add all of them, it gives 43. So some operation did not require any movement of your data within the machine. So that is a kind of a narrow transformation, right? So the same way count function is a narrow transformation. So this was the difference between wide and narrow transformation and how shuffle plays a role in creating a performance bottleneck. That's all for today, guys. Thank you very much. Have a great day ahead. Bye.